Properties of magnets. Yes. First property is that you are given a magnet, any magnet, north, south. Do you think the magnetic strength, the pole strength or the magnetic field strength nearby remains the same? No, it is different at different positions. For example, if you bring a north pole nearby here, north and north will repel. Here also repulsion, repulsion, repulsion. At this point, north and south will attract. That means between this point and this point, nature changes from repulsion to attraction. That is why if you plot, if you use a method to represent the strength, this is how the pole strength is represented. At the center it is almost neutral. That is why it is not the face where the north pole exists. The center of this, I mean the effective part, equivalent, is not at the face but somewhere inside. And this length is not same as physical length of the magnet. It is approximately 90% of L. So, the first part, the attraction appears to be maximum at the two ends of the magnet. The effect of the magnet is minimum at center of magnet. Competition, you get this type of, that it is 7 by 8 of L, 8 by 9 of L, approximately this is 90% of L. 1. 2. What is the magnetic meridian? Point number 2. A vertical plane, magnetic meridian, is a point, is a line, is a plane. What? Is a plane. So, one of the objective question, magnetic meridian is what? Magnetic meridian is a plane. A vertical plane passing through north-south line of a freely suspended magnet is called magnetic meridian. Let us perform the experiment here. Take a magnet and at the center have a thread and take this thread to a point of suspension. So, you moved it to this. Displace it. If you displace it, this magnet will have a tendency to align itself along which direction? North-south direction. So, point of suspension, one point, north, second point, south, third point. Join all these three. When you join all these three, that plane is termed as what? Magnetic meridian. So, north face, one point, south face, another point. Point of suspension, S. Join all these three. This triangle, this shaded plane is magnetic meridian. Third, like poles, sorry, like poles, yes, repel. Unlike poles, yes, attract. So, south will repel, south, north will repel, north will attract, south. Time with you is 4 minutes to write point number 1, 2, 3. 4 minutes to write. First point, those are late can have an idea again. North face, south face, the effect is maximum nearby the poles. If you bring a north, north will repel north. If you take this north, here south will attract. That means it will, in between the two, you have a point where magnetic field is almost 0, the effect is 0. So if you plot it strength wise, then this plot gives you fair idea about the strength of a pole. North is not on the face, south is not on the face, it is some distance in. What that distance is? 90%, approximately 90% of length. Then you come across meridian, magnetic meridian, thread point of suspension. So 3 points, north face, south face and point of suspension, 3 points. Join all these 3 points, this plane is known as magnetic meridian. 2 minutes more. Point number 4. If there are 2 charges, Coulombs law, yes. For charges, here for magnets. If there are 2 charges, Q1 and Q2, separated by distance R, force between the two, yes, 1 by 4 pi epsilon naught Q1 Q2 by R square. Now if there are 2, no doubt there are no independent poles. In magnets, whenever you have a north, you have a south. Don't have independent poles. So if the magnetic strength of one face is M1, second is M2, distance is R, force is equal to, we have covered 1 by 4 pi epsilon naught in electric is equivalent to what in magnetism? Yes, so that you can answer by N lagi. Charge equivalent is M1, Q2 equivalent is M2 by R square. 2 minutes to complete. Point number 5. If you have a magnet, magnets exist in pairs. Strength of the 2 faces remains same. If it is north face is plus M, south is minus M. Reason is lines. If one line leaves, it will enter back. Number of lines leaving the north face is equal to number of lines entering the south face. Complete loop. Suppose the distance between the two is 2L. Then magnetic dipole moment. How you defined electric dipole moment? Charge into distance. How you define magnetic dipole moment? Pole strength into distance. Is it a scalar quantity or vector? It is a vector quantity. What is its direction? Same, negative to positive. Here, south to north. South to north. Now, if you cut this magnet in two equal parts, there are two ways to do that. Like this one. How can you make two pieces exactly? Two number of ways. One way is, this is the length. You have a cutting plane perpendicular to the length. This is the length. You have a cutting plane perpendicular to the length. We will cut it in two parts. So, method number one is, this is the original magnet. You cut it in two parts. When you cut it in two parts, what you get is minus m plus m minus m plus m. This total length was how much? 2L. This is L. This length is also L. What is the magnetic moment of this part only? M into L. What is the magnetic moment of this second? M into L. Total is how much? 2mL. So, total magnetic moment remains the same. It is just like you have a 100-gram object, you cut it in two pieces, each is 50-50, so total mass remains the same. Another possibility, you have a magnet, the cutting plane is parallel to the length, you can cut it like this also. If you cut it like this at the center and parallel to the length, this is length is how much? 2L. This is how much? Minus m. This is how much? Plus m. Now, when you cut in two parts, now the face, if there are total number of lines, 1, 2, 3, 4, 5, 6 lines coming, this will have how many lines coming? 3. This will have how many lines coming? 3. That is why the pole strength reduces to half, m by 2, m by 2. And the length remains the same. So, magnetic moment of first part, this part only, m by 2 into 2L plus second part dotted, m by 2 into 2L, it is ml plus ml, comes out to what? 2ml. Again, the total magnetic moment remains the same. So, when you cut it in two equal parts, then the total magnetic moment remains same. Time with you is 3 minutes.